Welcome to the St. Joseph College for Women, Autonomous Visakhapatnam, Department of Mathematics. Welcome you for the online course on Real Analysis, Module 3, Infinite Series. Myself, I am G. Yojana, Assistant Professor, Department of Mathematics, St. Joseph College for Women, Visakhapatnam. Today, in this module, first theorem is D'Alembert's test or ratio test. Statement: if sigma un is a series of positive terms such that limit u of n plus 1 by un is equal to L, then we have three cases. First case, sigma un is convergent if L less than 1. Sigma un is divergent if L greater than 1. Test failed to decide the nature if L equal to 1. Proof: given that sigma un is a series of positive terms such that limit u of n plus 1 by un is equal to L. That is already given in the statement. Since un greater than 0, that implies limit un plus 1 by un is equal to L, that is also greater than or equal to 0. Since limit u of n plus 1 by un is equal to L, so by the limit of a sequence definition, it can be written as for each epsilon greater than 0, there exists m belongs to n such that mod u of n plus 1 by un minus L less than epsilon for all n greater than or equal to m. That implies modulus means plus or minus. So minus epsilon less than u of n plus 1 by un minus L less than epsilon. This can be written as L minus epsilon less than u of n plus 1 by un less than L plus epsilon for all n greater than or equal to m. Now here put n equal to m, comma m plus 1, comma m plus 2, so on n minus 1 in the above. We get that implies L minus epsilon less than u of m plus 1 by um less than L plus epsilon, L minus epsilon less than u of m plus 2 by u of m plus 1 less than L plus epsilon, and so on. L minus epsilon less than un by u of n minus 1 less than L plus epsilon. Now multiplying these above n minus m terms, we get in the left side we should multiplying L minus epsilon up to so on n minus m. So therefore L minus epsilon whole power of n minus m less than un by um. So u of m plus 1 by um. Next term. So common term, similar terms cancel in the middle term. Finally we will get un by um. That is less than L plus epsilon whole power of n minus m. That can be written as L minus epsilon whole power of n minus m into um less than un less than L plus epsilon whole power of n minus m into un. Again this can be written as L minus epsilon whole power of n by L plus epsilon whole power of m into um less than un less than L plus epsilon whole power of n by L plus epsilon whole power of m into um. Again this is can be written as a into L minus epsilon whole power of n less than un less than b into L plus epsilon whole power of n. So that is equation 1, where a is equal to um by L minus epsilon whole power of m and b is equal to um by L plus epsilon whole power of m. Now case 1, if L less than 1. So choose epsilon greater than 0 such that L plus epsilon less than 1. From equation 1 can be written as un less than b into L plus epsilon whole power of n. By geometric series, sigma L plus epsilon whole power of n is convergent. Why? Because L plus epsilon is less than 1. So by the comparison test, sigma un is convergent. Now case 2. If L greater than 1, choose epsilon greater than 0 such that L minus epsilon is greater than 1. From equation 1, how to we can take a into L minus epsilon whole power of n is less than un. It can be written as un greater than a into L minus epsilon whole power of n. So by the geometric series, sigma L minus epsilon whole power of n value, what is that? Divergent. Why? Because L minus epsilon is greater than 1. So from equation 1 satisfy this condition. So by the comparison test, sigma un is divergent. Now third case, if L equal to 1. So consider un. What is the un value here? 1 by n. where un is equal to 1 by n. Now we can calculate the limit u of n plus 1 by un is equal to limit of, what is the u of n plus 1? 1 by n plus 1 by un value, what is that? 1 by n. Then it can be written as limit n by n plus 1, that is equal to limit n by the denominator n taking common 1 plus 1 by n, and n get cancelled, so limit 1 by n value 0. So finally we can simplify, we will get that value. So by P series test, sigma un is divergent. Again consider sigma un is equal to sigma 1 by n square, where un is equal to, here what is that? 1 by n square. Now again calculate limit u of n plus 1 by un is equal to limit, what is the u of n plus 1? 1 by n plus 1 whole square by un is equal to 1 by n square. Then it can be written as limit n square by n plus 1 whole square, that is equal to limit n square by, in the denominator n square taking common 1 plus 1 by n whole square. N square get cancelled, so limit 1 by n value 0. Substituting and simplify, finally we will get 1. So by P series test, sigma un is convergent. Therefore the test failed to decide the nature if L equal to 1. Hence the theorem is proved. Note, by using this theorem, the ratio test is used when the factorial or product of conjugated terms are involved in un. In this case, we can use the ratio test. Now, problems on ratio test. First problem. Test for convergence 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial plus so on. So what you observe in this problem, factorial notations are involved. So now we can use the ratio test. Solution. Let sigma un is equal to sigma. The above problem can be written as 1 by n factorial. So immediately we should calculate the limit u of n plus 1 by un is equal to limit, what is the u of n plus 1? 1 by n plus 1 factorial by 1 by n factorial. That can be written as limit n factorial by n plus 1 factorial, that is equal to, so we can simplify, we'll get limit 1 by n plus 1, that is equal to limit 1 by, in the denominator n taking common 1 plus 1 by n. So limit of 1 by n value, what is that? It is 0. So limit u of n plus 1 by un equal to 0. Here L value is 0, that is less than 1. By the ratio test, our series sigma un is convergent. And second problem. Test for convergence 1 by 2 plus 1 into 3 by 2 into 5 plus 1 into 3 into 5 by 2 into 5 into 3 plus so on. Here some of the conjugators are involved, so we can use the again ratio test. Now here un is equal to, what is that? 1 into 3 into 5 into so on 2n minus 1 by 2 into 5 into 8 into so on 3n minus 1. So immediately we should calculate the limit u of n plus 1 by un is equal to limit of, what is the u of n plus 1? 1 into 3 into 5 into so on 2 into n plus 1 minus 1 by 2 into 5 into 8 into so on 3 into n plus 1 minus 1 into un value. And now finally we can simplify, we'll get limit of 1 into 3 into 5 into so on 2n minus 1 into 2n plus 1 by 2 into 5 into 8 into so on 3n plus 1 into 3n plus 2 into 2 into 5 into 8 into so on 3n minus 1 by 1 into 3 into 5 into so on 2n minus 1. That is equal to limit 2n plus 1 by 3n plus 2. That is equal to limit of numerator n taking common 2 plus 1 by n. In the denominator n taking common 3 plus 2 by n. And n get cancelled and limit of 1 by n value 0. So 2 plus 0 by 3 plus 0, that is equal to 2 by 3. So limit of u of n plus 1 by un is equal to 2 by 3. Here L equal to 2 by 3. It is less than 1. So by the ratio test, sigma un is convergent. In the same third problem, we have factorials are involved. So by using the ratio test, we can find the nature of the series. So that is a practice problem for you. Next, fourth problem. Test for convergence 2x plus 3x squared by 8 plus 4x cubed by 27 plus so on x greater than 0. So solution. First we can consider the nth term. So let sigma un is equal to sigma of n plus 1 into x power of n by n cube. So in this expansion take n equal to 1, we will get 1 plus 1 into x power of n by 1 cube. It is nothing but 2x. And n equal to 2, we will get 3x square by 8. N equal to 3, 4x cube by 27. So based on that, first we can take the nth term, that is n plus 1 into x power of n by n cube. So based on that, first we can choose the un and immediately calculate the limit of u of n plus 1 by un is equal to limit of u of n plus 1. What is the value? N plus 2 into x to the power of n plus 1 by un value. What is that? Un value, what is that here? N cube by n plus 1 into x power of n, that is equal to limit of, in the numerator n taking common, 1 plus 2 by n by n, in the denominator n cube common, 1 plus 1 by n whole cube into x into n cube by n into 1 plus 1 by n. So in the numerator denominator n cube get cancelled, limit 1 by n value 0. So everything substitute, we will get finally x value. So by the ratio test, sigma un is convergent if x less than 1. In case x value less than 1 mean, by the ratio test our series is convergent. In case x greater than 1 mean our series is divergent. In case x equal to 1, we can our series is test failed. So if in case x equal to 1, un can be written as how much, girls, here? N plus 1 by n cube. So let sigma vn is equal to, from un we can take vn. Vn is equal to sigma 1 by n square. So by the p series test, it is convergent. So limit un by vn is equal to limit of un value, what is it here? N plus 1 by n cube. Vn equal to, what is that? N square. So n square, 1 n square get cancelled. In the numerator n taking common, n into 1 plus 1 by n cube into n square. N cube cancel mean finally we can simplify. So limit of un by vn is equal to 1. That is L not equal to 0. So by the limit comparison test, sigma un is convergent. Next one, Rabi's test. Statement. If sigma un is series of positive terms such that limit n tends to infinity, n into 1 minus u of n plus 1 by un equal to L, then sigma un is convergent if L greater than 1. Sigma un is divergent if L less than 1. Test failed to decide the nature if L equal to 1. Based on that, problems. First problem. Test for convergence, sigma 2 into 4 into so on 2n by 5 into 7 into so on 2n plus 3. So first solution, let un is equal to 2 into 4 into so on 2n by 5 into 7 into so on 2n plus 3. Immediately we should calculate the u of n plus 1, that is equal to 2 into 4 into so on 2n into 2 into n plus 1 by 5 into 7 into so on 2n plus 3 into 2 into n plus 1 plus 3. Immediately we should calculate the limit u of n plus 1 by un, that is equal to limit of, write down the u of n plus 1 into Vn, that is equal to limit of 2n plus 2 by 2n plus 5, that is equal to limit, in the numerator n taking common, in the denominator also n taking common, in the numerator and denominator n get cancelled and limit of 1 by n value 0. So we can finally simplify 2 plus 0 by 2 plus 0, that is equal to 1. Now here we will get test failed to the ratio test. Immediately by using the Rabi's test, we should calculate limit n tends to infinity n into 1 minus u of n plus 1 by un is equal to limit n into 1 minus, right now we should calculate u of n plus 1 by un value. What is that here? 2n plus 2 by 2n plus 5. So limit of n into, we can simplify, we will get 3 by 2n plus 5, that is equal to limit 3n by the denominator n taking common 2 plus 5 by n, that is equal to n get cancelled, 3 by 2 plus 0, that is equal to 3 by 2. So here L value, what is that? 3 by 2, that is greater than 1. So by the Rabi's test, our series is convergent. Now second problem, based on the Rabi's test. Test for convergence, sigma 1 into 3 into 5 so on 2n minus 1 by 2 into 4 into 6 so on 2n into x to the power of n minus 1, where x greater than 0. First take, let un is equal to, what is our un value? 1 into 3 into 5, so on to n minus 1 by 2 into 4 into 6, so on to n into x to the power of n minus 1. Based on that, immediately we can calculate the u of n plus 1, that is equal to 1 into 3 into 5, so on to n minus 1 into 2 into n plus 1 minus 1 by 2 into 4 into 6, so on to n into 2 into n plus 1 into x to the power of n. Next, calculate limit of u of n plus 1 by un is equal to limit of. So, do you know value of u of n plus 1? Write down here into by un value. Do you know that? That is also write down here. And finally, simplifying, we will get limit of 2n plus 1 by 2n plus 2 into x. That is equal to limit of, in the numerator n taking common, 2 plus 1 by n by the denominator n taking common 2 plus 2 by n. So n in the numerator and denominator n get cancelled, and also limit 1 by n value 0. Substituting here, we'll get 2 plus 0 by 2 plus 0 into x, that is equal to x by 2, that is equal to x. So by the ratio test, sigma un is convergent when if x less than 1, sigma un is divergent if x greater than 1. In case if x equal to 1, our test is failed. So by using the Rabbit's test, first we should calculate limit n tends to infinity n into 1 minus u of n plus 1 by un is equal to limit n into 1 minus. So do you know value of un plus 1 by un? What is the value here? 2n plus 1 by 2n plus 2. That is equal to limit n into, it can simplify, n by 2n plus 2. That is equal to limit limit n by n into 2 plus 2 by n. So limit n square by n into 2n plus 1. Here n square and 1 n square cancel. We will get 1 by 2 plus 0. So that is equal to 1 by 2. It is, what is that? L value is less than 1 by the Rabbit's test. Therefore sigma un is divergent. Thank you.